Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 19, 2025, which was just 2 days ago. The big idea is a knowledge distillation pipeline that keeps the visual quality of 3D Gaussian splatting while slashing the number of Gaussian primitives by around 86 to almost 90%, and even nudging peak signal-to-noise ratio higher by up to about 0.62 decibels. The paper is titled Distilled-3DGS, Distilled-3D Gaussian Splatting, and as we'll see later, the efficiency gains are pretty striking. Broadly, the work blends multi-teacher supervision with a spatial histogram loss to train a compact student that renders high-fidelity views on limited hardware. Building on that, the tweets spotlight a multi-teacher setup plus a voxel histogram structural loss that trims Gaussians while boosting quality, with a short explainer video and solid engagement around 100 likes. Also, the authors shared the code on GitHub. You'll find a concise README with the TLDR abstract and pipeline overview for Distilled-3DGS, plus an assets folder and recent commits. The repo lists authors and affiliations, notes the ARCs for and project page update, and outlines teacher-student distillation and structural similarity loss. On the left, we are looking at side-by-side renderings that compare ground truth, the distilled student, mini-splatting, and standard 3DGS. You can see sharper textural details in the student crops, which stand out because edges on the desk and piano remain crisp at much lower Gaussian counts. On the right, the scatter plot summarizes the trade-off. The green star sits higher with fewer Gaussians, so quality improves while storage drops. Overall, the visual and numeric cues align with the multi-teacher plus histogram approach. Alright, we are looking at the pipeline diagram that lays out the two-stage multi-teacher to student flow. On the left, you can see initialization from structure from motion, which seeds 3 teacher branches. Moving across, the top branch adds parameter perturbation, the middle uses dropout, and the bottom follows standard training, so their renders provide diverse supervision. At the bottom row, the pruned student is trained with 2 signals, a structure similarity loss, and a color loss fused from the teacher renders. Next, we are looking at the spatial distribution distillation diagram, which shows how student and teacher point clouds become voxel histograms. The center cube illustrates voxelization, where the 3D space is split into a regular grid so counts per cell capture structure. On the left and right, you can see student and teacher point sets feeding in. At the bottom, the green and blue bar charts depict the normalized histograms that are compared with cosine similarity. Now we are looking at the big comparison table, which reports quality and efficiency across 3 datasets, with peak signal-to-noise ratio, structural similarity, learned perceptual distance, and the number of Gaussians. You can see the method sitting at or near the top for peak signal-to-noise ratio and structural similarity on MIP NERF 360 and deep blending, while keeping the Gaussian count very low. Building on earlier visuals, the efficiency row shows counts around 0.25 to 0.49 million, which is far below standard 3DGS. Overall, the trade-off clearly tilts toward fewer primitives with equal or better fidelity. We are looking at a table that analyzes the spatial histogram grid size, which directly affects quality and memory. You can see that moving from grid size 32 to 256 steadily raises peak signal-to-noise ratio and structural similarity, while learned perceptual distance slightly worsens. The trade-off appears modest in quality, but training memory climbs sharply, from about 9.5 gigabytes to more than 15 gigabytes. So, finer grids help alignment of spatial structure, yet they demand substantially more memory during training. Continuing from the grid analysis, the story is clear. The multi-teacher distillation, plus the voxel histogram loss, preserves structure while cutting Gaussian counts by roughly 86 to 90%, and quality even ticks up. A voxel histogram is a 3D grid of occupancy counts that captures shape statistics. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.